Good morning, children. I hope you are all safe at home and also studying at the same time. So today we are going to discuss about the types of acids and bases. In this chart, we can see that acids can be classified based on four different categories. First one is based on sources. So in this category we can get two types of acids, that is organic acids and inorganic acids. So what are organic acids? Organic acids are those which we can get from natural sources. So naturally occurring acids are called organic acids or natural acids. As you can see in the chart that the malic acid we get from apple, citric acid is in the lemon, oxalic acid is in the tomato, tartaric acid we can get in black grapes or the tamarind, lactic acid in the milk, and those bees, wasps and ants are having some burning sensation when they bite us, so they are having formic acid in their body which they use to attack the invading persons or any other threats. Next is inorganic acids. So inorganic acids are those which we get from inorganic sources. So they are not found in the naturally occurring substances. So here you can see hydrochloric acid HCl, nitric acid HNO3, sulfuric acid H2SO4, phosphoric acid H3PO4 and carbonic acid H2CO3. Now you can see carbonic acid is made from the carbon dioxide. When dissolves in water it is getting H2CO3 and that is called carbonic acid. So it's clear that two inorganic substances CO2 and H2O are chemically interacting to each other to form the inorganic acid. Next category is based on ionization. Here we get strong acid and weak acid. So how we identify that? See, in the diagram you can get HA. H is the replaceable hydrogen of the acid and HA is the acid, where A minus is the blue dot and red dot is A plus. So according to our definition of acid, in the solution this HA one arbitrary acid will give H plus ion in the first solution. So you can see here in the aqueous solution of the given diagram, most of the acids are not dissociated. Only a fraction of the molecules are dissociated. You can get only 2 or 3 red dots which are individually moving in the aqueous solution and rest of the molecules are intact. So when in the aqueous solution the molecules of acids are dissociated, only a small fraction of them, then that is called weak acid. So what is strong acid? Strong acids are those whose all the molecules are dissociated. That is 100% dissociation of the acid molecules in the present aqueous solution. Here you can see the acid HA are having H plus and A minus, two counterparts ions, and all the H plus and A minus are dissociated and individually moving in the solution. So HA is strong acid. Now it is same about the bases. If all the molecules in the base are dissociates 100%, it is called strong base. That means they are giving the OH minus from all the base molecules present in the aqueous solution, then they are called a strong base. And if some of the molecules are giving the OH minus ion in the aqueous solution, so that they are not completely dissociating in the aqueous solution, then it is called weak base. Here are some examples. You can see 6 strong acids are given over here. Among them, hydrochloric acid, sulfuric acid, and nitric acids are well known. And others 3 strong acids are perchloric acid, HClO4, hydrobromic acid, HBr, and hydroiodic acid, HI. All these 6 acids are basically inorganic acids. So we can tell most of the inorganic acids are strong acids. And from the strong bases, you can easily understand that lithium hydroxide, sodium hydroxide, potassium hydroxide, and calcium, strontium, and barium hydroxides are mostly from group 1 and group 2 metals. So if the group 1 and group 2 metals are forming the hydroxide, those bases are strong base. Here is the example of 2 inorganic acids which are weak acids. Those are phosphoric acid and carbonic acid. Both of these weak acids are found in soft drinks. Now, soft drinks are basically carbonic acid where carbon dioxide are dissolved in the water in high pressure and we are getting that carbonated soft drinks. So they are weak acids. So we can consume them though they are not very good for our health. Next category is based on basicity. Here we can get 3 kinds of acids and they are called monobasic, dibasic or tribasic. So what is basicity of the acids? The number of replaceable H plus ions in one molecule of acid is called basicity. Or simply we can count the number of H atom present in one molecule of an acid is called the basicity. Based on that, you can see HCl gives one H plus ion in the aqueous solution, H plus Cl minus. So it is monobasic. H2SO4 gives 2H plus ion in the aqueous solution. So it is dibasic. H3PO4 phosphoric acid gives 3H plus ions in aqueous solution. So it is tribasic acid. Similarly, in the case of base, we can get the acidity of the bases. So the number of replaceable OH minus ions in one molecule of base is called acidity of bases. Or simply we can count the number of OH minus present in one molecule of base. That is acidity of bases. Now if we take examples, we can understand that NaOH gives Na plus OH minus. So one OH minus, it is monoacidic base. Calcium hydroxide CaOH whole twice gives 2 OH minus in aqueous solution. So it is diacidic base. Aluminium hydroxide AlOH whole thrice gives 3 OH minus in aqueous solution, so it is triacidic base. The last category is based on concentration. So it is concentrated acid or base and dilute acid or base. Concentration is based on the portions of solute and solvent present in a solution. So like that, dilute acid or base means small amount of acid or base in the unit volume of total solution, and concentrated means large amount of acid or base per unit of volume. So our concern over here is the solute, that is acid or base molecules, and the solvent, that is water. So if the more number of acid or base molecules are dissolved in the water, then it is concentrated acid or base. Now if less number of acid or base molecules are dissolved in the same amount of water, then it is dilute acid or base. Next conflict is Is the strength and concentration same? No, they are not. So you can have strong dilute acid and also weak concentrated acid. To be very clear, the first term is concentrated. Concentrated means more number of acid or base molecules. So here you can see both the case there are many molecules. Now next is strong or weak. Now strong means all the molecules are dissociated, 100% H plus and A minus you can see. For the weak case, many are undissociated and very less number are dissociated. You can see only 2 H plus and corresponding anion A minus, but most of them are undissociated. So it is weak acid, but there are many solute. So it is concentrated weak acid. Next is dilute. So dilute, strong or weak acid or base. Now dilute means very less number of acid or base molecule. Here you can see very less number of it. Now next is strong or weak. So strong means those less number of solutes are completely dissociated. So you can see 100% H plus and A minus. But in the case of weak, there are undissociated H and dissociated very less number of HA. So 1 H plus A minus and rest are undissociated. So they are weak acid. So to conclude, it is possible to have concentrated weak acid having the presence of lots of molecules but very little dissociation of the acids, and dilute strong acids with presence of very less number of acid molecules having high level of dissociation. Thank you children for your patience. Stay safe at home and study well. Goodbye.